You are on Chapter 8, Part 11. In this video, you will learn about arrays of strings and C-strings or character arrays, another way to declare a two-dimensional array, and multidimensional arrays. You will also watch a quick review of the chapter. Arrays of strings can be manipulated using the data type string or character arrays, which are also known as C-strings. Arrays of strings and the string type. The example below declares an array of 100 components of type string. So here's our data type, and here's our array, and we have 100 items in this array, okay? So we're going to have 100 string elements in the array. Or it could be a list of names, could be a list of cities, we don't know. It's a list of 100 string data types. Basic operations such as assignment, comparison, and input-output can be performed on values of the string type. So we can do things with this. The data in the list can be processed just like any one-dimensional array. So it works just like a one-dimensional array. All right, so remember we said we have character, list, 100. So we have an array made up of characters, various characters, right? So this is arrays of strings and C-strings. So this is a character array. So we have character, list 100 items in the list. So this list down, starting with 0, 100 items, okay, all the way to 99. That 99, since we started with 0, that would give you 100 elements. But each element has no more than 16 items in it. Actually, you have 15 characters long because we have to have one character for the null character value. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, 16 characters for those string values, okay? So you can't have a name more than 15 characters in that name because the 16th has to hold your null character value. So if I copy a string value into the index location position 1 of my list array, okay, then I put, quote, Snow White. This is my string value, and I can put it on the array list number 1, index 1, and with each character, that's why it's called a character array, each character gets a location in this table, and then there's our null value, okay? So that's what it would look like in memory. Remember what typedef can do? Remember that it allows you to create an alias. So you can use this to declare an array. So here we have a constant integer, so we know it's integer. It's not going to change in value because it's a constant. And this is our variable, number of rows, there's our variable, equal 20. So we're going to make the total number of rows we have to 20. Constant integer number of columns, and that's equal to 10. So this is our variable, number of columns. It's integers stored in it, and we've got up to 10 of them. Typedef, so we're going to use an alias, integer table type, number of rows, number of columns. Okay? So now I can use table type and then matrix. Okay? So this is my data type. My data type, I turned type definition into integer table type. I've turned it into table type, number of rows, number of columns, and then this is my matrix, the name of the array. Okay, so this declares an array with 20 rows and 10 columns because we defined it here. That's what this does. It declares an array using typedef and alias. If a two-dimensional array is like a table, what do you think a multi-dimensional array must be like? If you think of a three-dimensional array, what would you picture in your mind? Most people would think of a cube. So let's look at this slide. How can we create multi-dimensional arrays? Well, you just list however many indices you need for those different levels of the array. So it's a collection of fixed number of elements arranged in n dimensions, however many dimensions you need, right? So you'd have your data type, integer, string, whatever it is, whatever the name you give your array, and then you have your index 1, index 2, and so on to however many indices you need, okay? If you wanted to access a particular component of that multidimensional array, you would have to put the array name and then whatever specific index, like this might be 5, this for row, column, and depth. So you might have 5, 14, 21, and that would be a specific memory location within that array. Now let's do a quick review of everything we've covered in this chapter. An array is a structured data type with a fixed number of components of the same type. Components are accessed using their positions in that array, and we use indices to determine that position. Elements of a one-dimensional array are arranged in the form of a list. An array index can be any expression that evaluates to a non-negative integer. It must always be less than the size of the array. The base address of an array is the address of the first array component. When passing an array as an actual parameter, use only its name, pass by reference only. A function cannot return an array type value. Individual array components can be passed as parameters to functions. In C++, C strings or character strings are null terminated and are stored in character arrays. Commonly used C string manipulation functions include strcpy, strncpy, strcmp, strncmp, and strlen. Parallel arrays hold related information. In a two-dimensional array, the elements are arranged in table form. In the last slide, to access an element of a two-dimensional array, you need a pair of indices, one for the row position, one for the column position. In row processing, a two-dimensional array is processed one row at a time. In column processing, a two-dimensional array is processed one column at a time. Okay, everyone, you just finished Chapter 8, and that's the last chapter for this semester. Congratulations, you have finished the last of Foundations of Programming 1. I hope you've learned a lot, and I'm sure I'll be seeing you around campus in the future.